Volume rock.
Jace, do you see the sample?
Yes, sir.
Okay. It's been 7 days. See, it's
All
nice.
right.
We prepared the concrete last week. I mean, not. I wasn't with y'all last week on Tuesday due to the hurricane. Class was canceled, but I did the preparation last week. I mixed the concrete. If you guys are able to see, I have the concrete bag right there on the corner. We use the concrete, and I'm assuming that you guys have already watched the video that I posted on Moodle. That video was made for Wednesday session of my class, but we follow the same procedure every semester. We mix the concrete from pre-mixed bags, quickly, and then we perform our slump test, measure the slump test, and right after we measure the slump test, we prepare our concrete cylinders. We usually get 3 cylinders, but we test 2 of them, and the last one is just for spare. Something happens during curing time, we use the spare ones. So far, everything is good. It's smooth this surface. If you can see the bottom, it's shiny, so smooth. But even though it's smooth, I'm gonna use 2 pads on both sides to evenly distribute the applied load on the cross section. So what I did was, I just tested the machine right before the class. I was testing different type of cylinders. Yeah, this cylinder was made, I think, last semester, so it's been over like 9 months, if I'm not mistaken, 8-9 months, and it went up to 200,000 pounds, which is quite a bit high load. If you can see, we're not gonna see this our concrete breaking parts like this sample, because this one was high strength concrete. You will see how it's gonna fail, and I'm gonna share the before and after pictures. I'm gonna take a couple of pictures before and then after, so you can explain on your discussion and conclusion parts how concrete fail, because there are different type of failure of concrete. Anyway, so I'm gonna take this sample out and then I'm gonna set up mine. Then we're gonna start testing. And the only reason I have this to protect myself, and I have my glasses, because if you test in high strength concrete, it explodes, especially if you increase the load suddenly. You know, if you go from 0 to, let's say, 70,000 pounds, and again in like less than a minute, it explodes, like this one. So these are the pads that we use, and the load is applied on the top of the top of the pad, and then it's evenly distributed to cross section. And then this is the gauge called compressiometer. It measures the deformation. So we're gonna set up to 0. From 0, we're gonna read the measurement. But for this particular experiment, I'm gonna let the software take care of the measurements, because I don't have anybody to help me to take the measurements, which is the load measurement is gonna come from that device, that handheld device, and the deformation will be written. We were supposed to read from here, but I will keep it here just for you guys to see how it's gonna work. But we will get the data from the software, which will be much more accurate.
Did you guys have any problem with the video that was posted last time? Did you guys understand the procedure? How we perform the slump test, how we mix the concrete? Okay. Okay, let's see. Now it's 0. I'll put the protector just in case. So before we start this experiment, can you tell me what is the maximum compressive strength we're expecting from this testing? Anybody knows what we're expecting? What are we shooting for? Don't be scared. So we're gonna test this material, right? We're gonna see how much its force is gonna take. And then we're gonna convert that force to PSI or KSI to measure what is the strength of this concrete. So in 28 days experiment, at the end of 28 days, we're expecting to have 4,000 PSI from this concrete, 4,000 PSI maximum compressive strength. But at 7 days, it's changing from 65% or 70% of the overall 28-day compressive strength. So 65% is around 2,400 or 2,500. That's what I'm expecting. If you look at the files on Moodle, you're gonna see the Quick Rig specifications. If you look at the specifications, you can see how much load it can be applied to concrete after 28 days, or what is the strength of this concrete after 28 days, and you can also see the strength at 7 days. So it should be 2,500. So just check it out. Anyway, so we're almost ready. I have to put the second pad on the top. Okay. I don't know if it's clear to see from here. I have to enter all the details, all the parameters into the software in order to start the experiment. For example, so I select the type of the experiment. It's a compression test. I can select tensile test, but today we're gonna do the compression, so I have to select compression test. And then I had to input the specimen height, 12 inch, and I have to enter the specimen shape. What is the shape? In this case, we are using a round shape. Also, I have to enter the diameter right here. So machine control. So I'm gonna let machine run the experiment because I already mentioned that I don't have my assistant here. I'm not gonna be collecting the data at the same time and writing on the board, so I don't have time for that. I don't. It's gonna be time consuming. So what I will do is I already set up the machine. So what's gonna happen is this machine is gonna apply 1,000 pounds per inch every minute. So every minute, this concrete cylinder will experience 1,000 psi. What I said at the beginning, we are shooting for 2,500, 2,600 psi because this concrete has been cured for 7 days, not 28 days. If it was 28 days, it could have been 4,000 psi, which was prescribed on the Quikrete specifications. If you look at your model, you will see, you will find the file, and then you can take a look at what is the maximum compressive strength of this concrete mix. So I say yes, okay, input the operator name, sample number one, and the diameter is 6 inch. And if I click test now, test will start. I don't know why gauge is tripping, but it's moving. It's moving up. And I'm gonna show you guys the graph. So software is already plotted the this load versus position graph, and I'm gonna export it to the exact spreadsheet, and I will share with you guys at the end of the experiment. Okay, now it's moving. Perfect. Okay, the peak load was so the peak load was 74,995. I'm gonna share this data as soon as we finish the class, and I'm gonna show how it's look like, how it's looking like after the take the frame out. Use the low version. Now we're releasing it. Okay. Like I said at the beginning, usually my assistant, he stays here, he reads the measurement. If you have the handout or if you have the sample report, you will see that on one column, you have the elongation or deformation, no, I'm sorry, deformation measurements. On the other side, you have the load measurements. So he's measuring the deformation as well as the applied load. And then I record it on the board, on the whiteboard. Then we share the information with students and they are preparing their own table. But in this case, I'm gonna get all the data from the software. The software doesn't even need to get the information from compressor meter because it's already measuring the displacement from this table because the table is moving up and the upper table is moving down. Its crosshead is moving down, so it's putting pressure. If you guys were here, if it was face-to-face class, you could have smelled the fresh concrete because it still has been curing. It's been 7 days only, has water inside. And I'm expecting to have a cone shape failure rather than 45 degree. In this case, let's see. Like I said, it's a cone shape. So on your report, you should explain one thing, why the failure type was cone shape, or what are the other type of failure of concrete compression test. There are 3 or 4 different type of failure, 45-degree, cone shape, and you should include on your report if you want to get extra points. Okay. On this sample, I mentioned Jace was here and Tuan was here at the beginning of the class. I tested this concrete. This concrete has been curing for over 6 or 8 months. I don't know the exact time, but it's from last semester. I went up to 200,000 pounds, which is way over 70 something thousand that we got for our sample. But if you look at the difference, this is still wet and this is fully cured, 99% cured. So if you increase the curing time and if you provide perfect curing conditions, you get better results. And I believe the failure was only on this side. The only reason failure was on this side rather than the other side, there was a stress development. That's what I'm assuming. The stress was developed on this side and the failure started from this section. That's my only assumption. I'm gonna clean the rest later on, and I'm gonna be answering questions if you guys have any question regarding the concrete, because we didn't have the concrete class last week. Instead, I posted a video from my other section. So, is everything okay with the class? Any complaint, any recommendation, anything so far? No, everything is good. So I was looking at the reports. This semester I have 2 TAs working for me because I am a TA and RA at the same time. But since I have more than 60 something students, I was given 2 other TAs to grade the papers because I cannot teach 2 sections and then grade all the papers by myself and focus on my research. So my TAs are working on the reports. I only read 1 paper. I select one of them. It was Janine Maus. It was her paper, and she got the 100th. She got an A, and this is the best report that I ever seen this semester. But I wasn't able to read all the reports. As soon as they submit the graded papers, I'm gonna share it on Moodle. Other than that, everything should be okay, because all the files that you need to finish up your report for concrete section, it's on Moodle. And for the last week lecture, whatever you see on the video, that should be enough for the first phase of your concrete compressive experiment, concrete compressive strength experiment. Like I said, this report including 3 different phases. The first phase is the preparation of the concrete cylinders and the slump test. And the second phase was today. To measure, we measured the load versus deformation. And then as soon as we finish the 28-day testing, we will compare the results between 7 days and 28-day testing results. So what changed between these 2 days testing? You're gonna look at the stress, you're gonna look at the strain, what happened to the deformation, what happened to the maximum compressive strength? Is it going up? Is it going down as the time increases? If you pay attention earlier, I said that concrete sample was made about 6 months ago, and the maximum load was around 200,000 pounds. So it tells you that if you increase the time, curing time, you're increasing the strength of the concrete. So I'm expecting to have more strength in the 28-day testing. So you should include on your report, once we get the result, with the time, with the increase on curing time, we are seeing increase on the strength. You're gonna have one table and you're gonna have one graph. I have this handout that I usually share with my students, but instead, everything is on Moodle, and I'm gonna show you guys how you need to develop your concrete report. I'm gonna share my screen for a second. So even if you didn't watch my video on concrete compression test section, there are 3 other additional videos that you can watch: how to mix concrete and instructions, and the slump test instructions. Okay, this was the spec that I was talking about earlier. You can see all the details, the product use, and how to mix it with machine or hand mixing instructions. And you can also look at this table to determine what is the compressive strength at 7 days. It's 2,500 psi. We got around 2,700 psi. And 28 days is 4,000 psi. And the slump range is 2 to 3 inches. I believe the slump was 2.75. And I'm going to share that slump information in the spreadsheet as well. So you should expect, what you should expect in this spreadsheet is here, sample concrete reports, concrete test handouts. Now, this file, you need to look at this file when you are writing your theory section, theory and procedure. I also highlighted the sections, the important sections that you need to remember and you need to add into your report. Not all of them, but most of them. Let's see, not this one. Okay. You need to have the first table. You can have 2 tables, or you don't have to include this table, but you should mention what type of, we should mention what is the shape. We should include the diameter and the area, etc. You can include these 2, you can combine these 2 tables into one. It's up to you. And you should include the expected compressive strength at 7 days and 28 days. It's up to you. And you can compare the results, what it was prescribed from the company and what we got at the end of the results, at the end of the experiment. So what you should get from me is these 2 columns, delta L, change in length, and the applied load for 28 days and 7 days. So you will get the 7 days today or tomorrow once I extract the files. And then you should use the same equations to calculate the stress and strain. And the equation was P over A to calculate the stress, and elongation divided by the gauge length is going to give you the strain. It's super simple. And you should include these equations in your theory section. Let me see, right here. So sigma is the stress, and you can find it by dividing the applied force by the cross-sectional area, and the elongation divided by the initial height or the gauge length. It's going to give you the strain. And you should also determine what the modulus of elasticity of the concrete is. There are two ways to find out. You can either use the second modulus. In other words, you can calculate the slope of the line that will give you the modulus of elasticity for concrete. It's similar to the tensile strength test. Or there is another equation that you can use. I don't know if it's included here, but I think I shared on my other files. There's an equation that was prescribed by ACI, American Concrete Institute. Let me find out where this is. Well, I can pull it up right here. ACI is 57,000 multiplied by square root of F prime C. ACI, modulus of elasticity. Right here, I was right. So this is the equation, 57,000 multiplied by square root of F prime C. F prime C is your concrete compressive strength, which is the ultimate strength of the concrete. So this value right here, 4,000 PSI, it's gonna go into this equation, and then you're gonna get your modulus of elasticity. And if you wanna drive this equation, and if you wanna see why this is 57,000, they tested these materials, these specimens over and over, and then they come up with this equation. This WC, it should be the unit weight of concrete. It is ranging from 1440 to 2560 kilogram per cubic meters. It should be 150 or 145 pound cubic feet. Let me see what is the concrete unit weight. Should be 145. Yeah, it's 150 pounds per cubic foot. But you can just use this equation to calculate the modulus of elasticity. It's easy for you. And if you calculate it using the graph, you can use this graph to calculate your modulus of elasticity. It's a plus. So you can use one or another. In this graph, you see that you have 7-day curve, 7-day plot, and then 28-day plot. And our goal is to figure it out, analyze why this strength is higher than the other one, or why this 28-day has more strain, has more deformation than the 7 days, etc. And you can include that information right here. And this was one of the reports that was submitted by my previous students. So if you don't include the modulus of elasticity, 7 and 28-day testing results, I'll take 5 points off. But rest is perfect. Any question? If there's no question, I can finish this class and we can continue next week. And next week, what we're gonna do is we're gonna look at the torsion experiment. From now on, I'm not gonna spend time on giving lectures because I'm not assuming that, and it's mandatory to have mechanics of materials lecture if you are or if you're enrolled in this class. So you should know the theory section before you come to the lab. I will just upload all the files that is essential for you to finish your report. I'm just gonna go over the files and explain how you need to put your report together. It's gonna save time for me, and it's gonna save time for you. And I will help you out if you get confused when you are developing your report. You already have your PowerPoint here. You already have video for torsion. So I strongly encourage you to watch these videos before you come to class and refresh your memories from mechanics of materials lecture. If you already taken the class last semester or in previous years, you can refresh your memories, or even if you're taking right now, it will be helpful for you to get better on your mechanics of materials lecture. Let's see what I included here. This is a torsion test, same equipment that we use. They made a video about it, and you can watch this video before we run the experiment, so you get familiarized with the experiment. And the rest should be the lecture videos. No, they are all testing, but I'm gonna add some lecture videos as well. And this was from 2017. This was my result, my calculations for the torsion test, or torsion experiment. You will receive similar type of template, Excel spreadsheet, but only thing will be given to you is the degrees of deformation and the applied torque. And you should calculate the rest. But as you can see, all the equations are given on the left side. So as long as you use these equations to calculate the required values, you should be good to go. And you're gonna have 3 graphs for each specimen. We're gonna be testing aluminum and tensile specimen, aluminum and steel specimen. Let's see. This is the handout that I usually give to my students. You can take a look at the handouts, and I'm going to go over the handout as well next week. Excuse me. This was from last year. Pretty much all the information that you need for the report is already in this spreadsheet. I prepared for the students for them to take a look at it and use it as a reference for their report. So it's better for you to study this before class, and it will be easy for you to understand when I'm teaching the lecture, because I'm not going to spend too much time on the teaching part. As you see over here, only data section, like I explained before, you're going to have the measured deformation in degrees, and you're going to have measured torque values, because we're going to be applying torque into the aluminum specimen or steel specimen. And this is your job to calculate these sections. And I already have the graphs and everything. So once you calculate this section, your graph will be ready for you. And all you got to do, copy and paste your report. You have your steel, pretty much everything that you need. And there is already one example that you can use, and all the equations are inside. So it's already calculated, and you can see the graphs. And if you look at it, you can see the similarity between tensile strength, tensile test, and torsion test. Usually torsion test is costly compared to tensile test, so they are using the tensile test information to predict the torsion test results. And I believe I mentioned it here, right here. Relationship between tensile yield and shear strength. There are no published standard values for shear strength, like with the tensile and yield strength. Instead, it's common for it to be estimated as 75% of the ultimate tensile strength. So we are assuming that the 75% of the ultimate tensile strength from tensile experiment is equivalent to shear strength from torsion experiment. And for steel, you can look at the relationship. I tabulated right here. Shear strength is ultimate shear strength is equal to 0.75, 75% of the ultimate tensile strength. For iron, it's 90%. For cast iron, is 1.3. Aluminum is 0.65. And you can look at the chemical composition of the materials that we're going to be testing. Pretty much everything. All you need to do, you need to summarize this information into your theory section of your report for the torsion. Okay. If there's no question, I will see you guys next week. Okay. Thank you.